The second lesson that I looked at was a ramp lab that I completed with my students during our Forces in Motion unit. So basically in this lesson, students were determining if a taller ramp or a shorter ramp would make a marble roll faster. So we started by just talking about our key vocabulary from the unit. We use a word wall and we discuss them through our word wall. Then we had students making a hypothesis, and on the page I wrote that a hypothesis is a statement that can be proved or disproved, so that students were reminded of what this was. And then they were deciding, will the marble move faster down a ramp that is taller or a ramp that is shorter? After they created their hypothesis, they then had to explain why they thought the way that they thought. And after that, we kind of set up the experiment, what it was going to look like. We used books and pool noodles to set up our ramps, and then discussing with students how to drop the marbles and how to collect their data. So then students went through, completed the experiment. As you can see, there's a chart where they X'd off whether ramp A or ramp B made the marble go faster, and then they just X'd as they went to collect their data. Afterwards, I had them drawing a conclusion, what happened, did the taller ramp or the shorter ramp make the marble roll faster? They then had to determine if their hypothesis was correct. And then last, this was given after they completed this sheet, why do you think the taller ramp made the marble roll down faster? And of course, they were talking about the amount of energy when an object is dropped from a higher point. The energy is increasing. So a little bit about the analysis of this ramp lab with the UDL guidelines. Under engagement, it was fostering collaboration and community. Students were working in groups together as they were completing this. There were 4 innate groups, so they were working together, dropping marbles together, collecting the data together. Developing self-assessments and reflections, so students were reflecting on their hypothesis and determining why the taller ramp made the marble move faster. And then representation, clarifying vocabulary and symbols, so students were given the definition of the word hypothesis, just as a friendly reminder of what that was. And then students reviewed the key vocabulary at the beginning of the lesson before we actually began the lab. Activating and supplying background knowledge. So students could have used their prior knowledge on speed and energy to help them in creating their hypothesis for this lesson. And then action and expression, facilitate managing information and resources. So the data collection table for the lab was doing that. Under the accessibility guidelines and under the sufficient color contrast, so students are able to see the text as it is just black and white. Lists, the steps to complete the lab were numbered as students went along, 1 through 6. And then the tables to collect the data was shown in columns and rows and had headings for each. And then Rice's Chapter 8, Principle 1, there was use of interactive simulations with the actual lab itself. Principle 2, the use of guided questions for self-monitoring and reflection, so reflecting on their hypothesis, answering questions as they were going. Principle 3, encouraging active participation, exploration, and experimentation, so the lab itself was experimenting and exploring what would happen when we dropped the marbles from different heights. And then providing opportunities for collaboration, so students were working together the entire time throughout this lab. Some possibilities for online science lessons. So Rice discussed incorporating hands-on activities through document cameras, which I can see being very beneficial in science. If you aren't able to find an interactive piece, you just showing it yourself could be helpful. Using virtual labs for activities, I'm sure there's many out there, even just on ClassFlow that I looked at last week. They had tons of math virtual activities that could be used in science. Sorry, I think I said math. They had tons of science ones that could be used in science. And then also having students set break timers. So this could go across all not just science, but I feel that sometimes science can have lots of tricky terms and a lot of information. So in any case, having students set break timers I found would be very beneficial. And then providing remediated versions of your lessons to students in breakout rooms. So I also think that, again, science can sometimes be a tricky topic, so providing that extra support could definitely be beneficial. And that's it for this one. Thank you.